Hello everyone, and welcome to today's webinar on designing resilient applications on Microsoft Azure. Good morning, good afternoon, good evening to the folks joining from different parts of the globe. My name is Noor Basha, a marketing director at Winwire Technologies, and I'll be your moderator for today's webinar. As you all know, today's topic for the session is how to prepare your applications to withstand disaster on the cloud. That is basically we will look into how you can build and design resilient applications using Microsoft Azure. So in the next 30 minutes, we will see some of the best practices, approaches, and also the case studies on this particular topic. So before we start, let me highlight few housekeeping items. During the webinar, please feel free to post questions and we will try to answer as many as we can at the end. And we are recording this session, so you will have the presentation as well as the recorded version in next 24 to 48 hours. So with that, let me take this opportunity to introduce you to today's session speaker, my colleague Ravi Kanchan, who is a technical consultant at Winwire Technologies. Ravi brings over 13 years of IT industry experience and is involved in architecting and implementing uh, customer-specific solutions in terms of migrations to Microsoft Cloud. So he also brings a deep expertise in the building enterprise-grade hybrid cloud system, leveraging Microsoft PaaS, SaaS services. So with that, let me hand it over to Ravi to take the session from here. Ravi, over to you.
All right. Thank you so much, Noor. A good day, everyone, and welcome to this session. And I appreciate you joining us today. My name is Ravi Kanchan, as Noor has already provided my introduction, so I won't waste any more time on that. But before starting, as I think Noor has already said, I would like to highlight it again that we'll take questions towards the end of the session. And I promise in next, I will leave enough time towards the end so that we can take questions and we can have interactive discussion about today's topic, right? So with this, this is the overall agenda, and this is what we are going to cover today. We will talk about the background. I will set the stage on what we are talking about and why. I think this is the most important thing to understand. Why we are talking about this topic today and why it is relevant for all of us. Then we'll talk about the approach for designing a resilient application on cloud, how we can do that, and best practices around that. And then we'll talk about, right after that, we will dive into a case study, very recent case study, which is very relevant to this topic, as well as it is, as I said, it is very recent. So, and based on some of the incident which happened last month, so it is perfect case study for today's session as well as for this topic. All right. So setting up the background. So when we talk about cloud computing or we talk about cloud platform, first thing coming to our mind is limitless storage, compute power, cool services, cutting edge technology around advanced workloads like data, AI, and whatnot. But one thing that we invariably miss out or kind of overlook and maybe and assume in such cases that what is the dependability? If I'm hosting an application on cloud, what is the resiliency my application is going to have? We know that most of the cloud service providers like Amazon, Azure, Google, they all claim that, okay, all this, that at the service level, they have upwards of 99.9% of SLAs. But we kind of overlook what does it mean to us, right? How my application hosted on one of these cloud platforms, can I go ahead as an IT team member and go to business and commit to these SLAs to them, that whatever application we are hosting on their platform will be adhering to this SLA? No, you cannot, because the reason is, and the reality of situation is, outages do happen. Because behind the cloud, it is brick and mortar data warehouses. There is cooling involved, power supply involved. There is weather issues, disasters happen, right? And manual intervention is involved in many of the scenarios. It means that people do make mistakes, disasters do happen. Your data center where you are hosting your application can go down, right? And there are multiple scenarios which has happened in recent past, and people, organizations have lost like millions of dollars because of that. But the good part of the story is that yes, you can gain control of your application and have overall set the fate of your application in such scenarios when a data center goes down, or a specific service on a data center goes down. How do you design? But it is not by default. So one thing is very important thing we need to understand is it is not by default. We have to plan for it. We have to design it. Deliberate design principles should be followed to have these applications resilient, right? And that is where you will be able to leverage the maximum benefit of cloud platform, where you have unlimited amount of compute power, latest technology, and a dependable application to back it with. With this, I will go into the principles of designing resilient apps. So over here, we have to change our mindset, right? Because coming from the on-premises scenarios to cloud platform scenarios, it is different, right? You have to change our mindset, which means that when you're on-prem, the way you think about resiliency is that, okay, I will buy greatest and best hardware available in the market, and which will provide the kind of dependability for my application. But on cloud, it's different, because you already have greatest hardware available to you, and there are data centers, multiple data centers spread across. But on cloud, what you have to do is you need to plan your application. When you are hosting your application, you have to spread across horizontally, across multiple data centers at each service level. That is what the mindset change we need to adapt to. There are two very important aspects of it, and this has not changed since the on-prem days, right? First, defining your application requirement, and then designing according to it. These are the two main elements we need to follow to have a resilient application on cloud. Requirements, which means that we need to define what is the meaning of availability for our application, right? Is it like I have a application hosted on cloud? Is it like my customers are able to upload or process, they are able to submit their request? Or is it like the system is able to submit, like customers are able to submit the request, but the system is able to process it or not, right? So we need to define that. What is the meaning of availability for us, right? When we say, okay, if this part of the system is down, then we say, okay, yeah, application is down, right? How much will potential downtime is going to cost you? How much downtime is acceptable? If these 2 points are pretty much related to each other, right? if the cost, you will do the cost benefit analysis and see, okay, this is the downtime which we can achieve. Data loss, this is a big piece in designing defining your requirements for your application on cloud or anywhere else, is how much data loss you can sustain, right? How much data loss is okay for you, and mixture of all. So when you do this level of analysis, the outcome are two very basic parameters, which defines RTOs and RPOs. So once you have your RTOs and RPOs defined, what happens is we need to design our application. And this is where things are slightly different from what it used to be before, right? Here, you have to identify, because application on cloud is a collection of multiple individual services, right? So we need to find out how many such services we are using. We need to find out the point of failures and likelihood of those failures and determine how your application is going to respond. For example, you have a database service which you are using, database service you are using at the backend. If that goes down, which means that your application is down. Now, on the other side, if you have Azure Data Factory service which you are using to get data from somebody else, some other system, if it goes down for a couple of hours, it's okay because you will not get the latest and the greatest of latest data from that system, but still your application will not be down. Right? So we need to do that analysis there. And then at the end of it, once you have done all that analysis at each service level, point of failure level, we need to define how at each service we are going to address the resiliency, because based on the analysis you have done. Okay? So these are the two key fundamental elements of designing a resilient application on cloud, right? And it has to be done. It should not be a separate. Activity. It should very well be part of your overall design and development process of your application. With this, without wasting time, I'll directly jump into our case study here. So this is a very, very interesting case study, right? The client is a major construction company headquartered in South Central region of US, and they have operations all across US. Recently, because they had a major push internally, and because of certain market scenarios, they invested heavily on an application, on a system, which enabled them to streamline and optimize their construction operations, streamline as well as optimize their site operations, centralized all data, do analysis on top of that data, and provide valuable input to their management team to make key decisions, right? So they did absolutely everything correct, right? They made a push. They invested on the right system, right cloud platform. Everything was right. One thing which they missed or overlooked or assumed was the availability. They assumed the resiliency of their application, right? And come September, there was a major outage in South Central region on Azure platform. What happened is, within a couple of months of the system going live, they suffered a major unexpected downtime. And unfortunately, what happened on the then single day, they had a major presentation to be done to the president of the organization, which means that ITVP is presenting to the president of the organization, and which will define the future of this system from the funding perspective and direction it will go to. On that very day, it happened, and you can imagine how much it would have costed overall, right? The operations was hindered, was interrupted, as well as the key decision making, which was supposed to happen, didn't happen that day, right? In a pickle, they reached out to us and to assist them in assessing their application, why they went wrong, as well as provide them steps and implement how they can, going forward, how they can build the resiliency on this application. All right. So with this, I'll just cover a very high level of this application, how it looked like. This is before we implemented, this is how it was. It was all the service components was hosted on South Central region. They are using PassWeb. They have storage account, SQL database, the VM, which is hosting a third-party tool API. They have Azure Data Factory, which is pulling in data from their on-premise ERP system. Overall, I think this what we are presenting is a very simplified form of their system. Just for the benefit of this presentation, I have simplified it. They have other SaaS systems which they were integrating, which they were pulling data in from. They were or pushing data to, right? Which I have not included over here, right? So that is what we did first. Understood what they had previously, and then we had multiple rounds of discussions with their IT team, their business team, their people on the ground, and their management team to identify what is the allowed RPO and RTO for them, what is acceptable to them. And the outcome was RPO. They said, okay, we are okay if we lose 30 minutes of data, and RTO is like, okay, if it's okay, we go down. If the system goes down, if it is okay for us to get back to on feed within 2 hours, right? So these are pretty relaxed from cloud perspective. These are pretty relaxed numbers, I should say. It gave us very quick, very flexibility to evaluate multiple options. But looking at multiple scenarios, other scenarios, we kind of zeroed in on two scenarios. First is the hot standby, where we have like the primary as well as the standby up and running always, and the cold standby, which is primary is up and running, secondary standby or secondary or standby we provision in the case of disaster, right? So this is how the system was initially. So first thing what we did is we identified what is the heart of that application. The heart of the application was if that goes down, that service goes down, they will lose data, as well as they will lose the application will not be available, will not be functioning, right? So we identified that database was that service which was the key, right? So first of all, what we did is we targeted that application, that service, where we enabled geo-replication with SQL failover group, right? With auto failover. So now what happens is once we did it, as the architecture look like right now, what you see, okay, anything that happens to Azure SQL Azure PaaS service on the South Central database, right? As soon as that happens, automatically it will fail over to the database instance on the Azure North Central US, right? So what we have done is we have built resiliency at the database level, right? Very similarly, we will go further. We did for their primary storage. So they were having a huge number of images being stored on these storage accounts, right? So what we did is we enabled geo-replication storage with read-only access. Okay, that is what That's how it is designed at this point. Doesn't and suppose the way it is designed on Azure is, suppose storage service uh, suffers some issue on one data center. Microsoft will take its own time. They do analysis. If required, then only they will fail over to the different data sets. Though we have a copy of the storage data, storage account data on the different data center, but they will not fail over. That the copy will always be read only till the time they forward, which means that we are giving control back to uh, the the cloud platform provider, where on the fate of us, right? So this is first step we have taken for that. Then we enabled, they had some, as I mentioned, the third party API hosted on their VM, a virtual VM. What we did is we provisioned the VM on the standby data center and introduced a traffic manager in between. So what it did is it like, and everything is fine, all traffic will go to the primary, and as soon as there is some issue on the primary, it will divert all traffic to the secondary side. Right. Coming back to the storage, right? As we know that for us to have, if in the case of a major failure, if we have to fail over to the standby, we need a storage account which is read-write, because we are reading as well as writing into the storage. We are creating new images and storing there. So what we did is we provisioned a new storage account, which we are calling a standby storage account, and we created a custom job, a custom Azure job, which sync the data from, which reads data from this read-only copy and copies there, which means that at any given point of time, my standby storage account is having the same version of the file which is there on the primary, and it is read-only, right? Moving forward is, and then once all the lower layer pipe fitting was done, plumbing work was done, we provisioned a new instance of the application on the standby, and we introduced a traffic manager, and this is how the option one looked like, which means that if anything goes down on primary, within seconds, failover will happen, automatic failover will happen on the standby side. This is the best architecture which you can imagine for this application, right? We didn't stop here. We evaluated multiple other options. This is the summary. I'll just skip through this. Over here, this is the cold standby. Very similar concept. The Azure application, storage, VM, traffic manager. But in this is the difference is that we did not provision any services on the standby side, right? So any service, if something goes down on the primary on the primary, what we are going to do, we will execute our PowerShell script, which will provision all these services and fail over, and all the traffic will be failed over to the standby side. Right? So this is how. So we had two options available to us. This is the summary. What RTOs and RPOs we were able to achieve. So if we go with option one, we had RPO of 15 minutes, which was well within what is required, and RTO of less than 30 seconds. 30 seconds itself is pretty pretty generous, right? It is much less than that. Option two is, okay, your RPO is same, but your RTO is 1 hour, because it takes time to provision these services on the case of outages, right? So both these options supported the requirements. But what we thought is, okay, let us calculate the cost. How much cost it is going to be if we go with option one, versus option 2. We did the cost analysis, so this is our standard Azure service cost calculation sheet. This is how it looks like. So overall, it was coming towards like around 5,000. If we go with option 1, sorry, I think this is still was it's 7,000 for option. So it is option 1 is 2. So what we saw is that okay, even if we go with option 1, it's just a few $1,000, couple of $1,000 extra if we go with option 1. So why not to go with option 1, right? At the end of it, what happened is because of the insignificant cost difference between option 1 and option 2, which means that option 1 is obviously much better than option 2 because there is no manual intervention required. If failover is almost instant. You're not doing anything. Your users may not even will realize that some downtime happened, right? So we went with option 1. Once we start implementing, we did rigorous exercise of failback and failover. We found that whatever we designed was actual the scenario where we were seeing very no to very little downtime. No manual intervention was required because it was complete automatic, and system is resilient enough. Now the system is resilient enough to withstand such kind of outages. Yeah, there are certain type of outages which we cannot avoid, like if Azure Active Directory is down or something like that. But majorly we can do that. I think that is it from my side. Noor, back to you.
Hey Ravi, thanks so much for taking us through the different options that are available and also a quick case study from the construction company. That's really useful. Yes, I have a couple of questions. One from Mark. So where he asked, how did you design and implement a failback scenario in the case which you have showcased?
All right. So yeah, I think this is a very good question, interesting question. Right. I just showcased all the happy scenario, right? Okay, everything has went fine, but I didn't talk about how the failback happened. But we need to understand that when failback happens, like in case of failover, it is unplanned. Failback can be planned, right? So in the option which we chose is only critical piece for us to design around failback was storage, data inside storage. So Delta new files which were added to the storage account. So we had a utility. Whenever we wanted to fail back, we will just run that as utility, and it will copy all the data. As soon as that is done, all the traffic will route back to the primary.
Thanks, Ravi. So another question is like, how much time did you take? Did you take to implement the solution which you just showcased?
Okay. Yeah, I think right. So this incident happened. Let me do some bad calculation. This incident happened early September. You can say it's like four weeks since then. Like a week of analysis, requirement, couple of weeks of implementation, and then testing. So I think yeah, I would say somewhere between 3 to 4 weeks overall.
Perfect. Thanks for that. So one more question. What is the starting point for assessing cloud system in order to achieve this resiliency?
Yeah, as I mentioned before at the start, right? The starting point is identifying your RTOs, which is very generic to say. But from cloud perspective, the most important activity is identifying your services you are using, your application is using, and identifying your point of failures. And that is, once you have identified that and how it is going to affect your application, if something goes bad, like half of your battle is done, right? Then beyond that is all you have to do is just configuring your services so that you can build resiliency on top of it.
Great. Thanks. I think we are almost there. I have a couple of more questions, but we'll take them offline. So again, thanks, Ravi, for taking us through this session and also taking up a few questions from the audience. Very appreciated. And thanks, everyone, for joining for this session. And I hope you found it informative and useful. If you need any information, you can tweet at Winwire or reach out to us at marketing@winwire.com. Thank you so much. Have a good day. Thanks, Ravi, again.
Thank you so much, guys. I appreciate Noor for the coordination and everybody else for joining us today. Thank you so much. Have a good day.